So let's start by talking about how we can rewrite an expression in both radical form and in rational exponent form. This is referred to as radical form. This is referred to as rational exponent form. Rational means a fraction. There's a fraction in the exponent position. These are equivalent forms. So as I go through and I simplify expressions today, recognize that if I received an answer like this, it could be rewritten in this form, and they both are correct. All right, we are going to start with learning how to simplify problems that look like this. So example number 1, please write it down as I go through it. Notice that my nth root is a 3, so make sure that 3 is small. I am naturally not very neat when I write. So example number 1, how do we simplify this expression? Well, first of all, there's 2 things to notice. Notice that we're multiplying, and we're multiplying 2 different radicals that have the same nth root. We need to have that. We're multiplying, and we have 2 different radicals that have the same nth root. So the first thing I do, it's very procedural, is I'm going to take the numbers outside that are the coefficients, and I'm going to multiply them. So 2 times negative 6 is negative 12. And I tell students when they're first learning this to go back and cross those out so there's no confusion. The next thing I'm going to do is I'm going to combine these. Now, before I combine these, I need to go back to what you learned in 9th grade. So let me just jump up here and let's review what you learned in 9th grade. If I give you this and I said, hey, can you simplify this? X squared times x to the third, what do you get? So you need to take a vote for me. Is it x to the 5th or is it x to the 6th? Or, I don't know. If you think it's x to the 5th, please give me a thumbs up in just a little bit. If you think it's x to the 6th, give me a thumbs down. If you're not sure, that's okay. Give me a thumbs to the side. Go ahead. You think it's x to the 5th? Thumbs up. X to the 6th? Thumbs down. In the middle, I'm sorry, I really don't remember. Okay, what is it? When you are multiplying and you have the same base, you add. Correct answer is x to the 5th. So let's come back down here. We are multiplying. We have the same nth root. So we're going to make this radical. Now, the values inside, these values inside of 4 and 16, I'm going to multiply those. So 4 groups of 16 is 64. Now, when I combine the A's, the B's, and the C's, I'm going to go just like I did up here. Same base and multiply, and I add the exponents. So I have the same base, and I multiply, and I'm going to add. 7 plus 2 is 9. 6 plus 12 is 18. 1 plus 2 is 3. I am definitely going to suggest you do not write down what I'm doing next. So this is like the expanded long way of doing it, but oftentimes kids are able to connect to the understanding of it before I teach you the shortcut method. Do not write down what I'm going to do next. Do not do that, okay? We are going to go here and go. These 2 expressions are equivalent. And you're like, well, what is all this garbage? All I did is I expanded it. So I took this 9. There's 3, 6, 9. I took this 18. 3, 6, 9, 3, 6, 9, 12, 15, 18. And there's a 3. I expanded it into groups of 3. And I was lucky because 9 is a multiple of 3 times. 18 is a multiple of 3 6 times, and 3 is a multiple of 3 once. Now, how do I go further? Well, I'd like you to take out this paper if you don't already have it out. We're going to use it today. And I'm going to start by simplifying this part. So I'm going to go into the nth root. This is 3. Go into column 3, and I'm going to see, is 64 there? Ooh, I'm lucky. 64 is there. I go straight across, and what does this mean? It means if I take 4 times itself 3 times, I end up with 64. 4 times itself 3 times is 64. So out of this part, I can simplify and pull out a 4. How many groups for the A, how many groups have 3? 1, 2, 3. There's 3 groups that have 3. For the B's, how many groups have 3? 1, 2, 3, 4, 5, 6. Bless you. How many groups have 3 for the C's? 1 group. My final simplified answer is negative 48, A to the 3rd, B to the 6th, and C to the 1st. This is my simplified answer from this original expression. Let's look now at number 2. Let's look now at number 2. All right, we're going to do another pretty one before it makes it more complicated. We're going to have 1/2 up front, 1/2 up front. 108, a to the 19, b to the 11, times 4/3, 2, a to the 3rd, b to the 2nd. So I'm going to start by multiplying the numbers out front. So 1 times 4 is 4. 2 times 3 is 6. That's not wrong, but I know that 4 over 6 could be reduced, right? 4 over 6 reduces to 2/3. They're both even. So I've taken care of 1/2 and 4/3. And now I'm going to combine these two radicals. How do I combine them? 108 times 2. Well, 100 times 2 is 200, and 8 times 2 is 16, so 216. Let's look at the A's and the B's. When I multiply and have the same base, I'm going to add 19 plus 3 is 22. 11 plus 2 is 13. And this is how it's going to slightly change. So again, one more time, I'm going to write it out in expanded form, but I would not do this if I were you. You can simply watch. I'm doing this for visual learners. After this point, we're going to do the shortcut. So I'm going to write in groups of 3. So I have 3, 6, 9, 12, 15, 18, 21. I got to get to 22. There's 1 left over. Now, for groups of 3s for 13. 3, 6, 9, 12. I have 1 left over. Can I have a thumbs up or thumbs down if you understand how I expanded it? Thumbs up, thumbs down if you understand. I would never take time moving forward to do this. I just want you to visually see how I'm doing it. All right, you ready? Go back to that paper. Go to column number 3 and see, is 216 there? Can I find 216? 216 is there. What does this mean? It means 6 times 6 times 6 is 216. So I have 2/3 times 6. By the way, that's the same as 6 over 1. So I think I'm going to go ahead right now and I'm going to simplify. 2 times 6 is 12. 3 times 1 is 3. 12 divided by 3 is 4. So I've got a 4 out front. Now, here we go. You ready? I have a 4 out front. How many groups of 3 do I have for 8? How many full sets of 3 do I have? 1, 2, 3, 4, 5, 6, 7. I have 7 full sets. I have 7 full sets. But there's a remainder. There is a remainder of 1. Anything that's a remainder must remain inside the radical. In this case, it's a cube root. How many full sets of 3 do I have for B's? 1, 2, 3, 4. I have 4 full sets, but there's a remainder of 1. This is the simplified answer. Now, if you are like me, you're like, Ms. Bradley, I don't want to take time to write all this out. Like, what could I do that's different? Well, as long as you're good with multiplying and you have good multiple skills, we can do this. Okay, what is closest to without going over? How many groups of 3 can I do evenly without going over? I can do 7 groups. 7 times 3 is 21. That's how I got a 7. But 21, well, there's 1 left over. There's 1 left over. How many groups of 3 at most can I go into 13? 4 groups. 3 times 4 is 12, but there's 1 left over. That's the other way to do this. You choose which way works best for you. So let's start right now by multiplying. So let's take 1/3 times 1. 1/3 times 1 is simply 1/3. Now I'm going to rewrite this. 4 times 2 is 8. How many A's do I have? 1 and 3 is 4. How many B's? 2 and 3 is 5. How many C's? 1 and 1 is 2. How can I go further? Well, I'm going to first focus on this portion. So I'm going to go to column number 3. I'm going to locate the 8. Column 3, locate the 8. Go straight across to receive 2. So 2 pops out of this. So I have 1/3 times 2. Well, 1/3 times 2 is like 1/3 times 2 over 1. So I end up with 2 over 3. So I have 2/3. Now, how many groups of 3 can I take out of 4? How many full groups? A little bit louder. 1 full group. So I can take 1 group out, but there's a remainder of how many? There is a remainder of 1. How many full groups of 3 can you take out of 5? 1 group. There's a remainder of 2. How many groups of 3 can you take out of 2? None. This would be my final answer. Now, if you're like, Miss Bradley, I just did not follow that. Well, let's take this and let's write it in groups of 3. So there's 1 group, but there's a remainder to get up to 4. Let's write b to the 5th in groups of 3. There's 1 group, but there's a remainder of 2. So if this was my radical, I'd say, okay, I can take 1 group out, but there's a remainder of 1. Okay? I can take out 1 group, but there's a remainder of 2. And here there's a remainder of 2. Let's look at our next problem. So are we going on to example 4 right now? Is that correct? Example 4? Okay, here's example number 4. We're going to take this as another timed setting. I have 5 halves times the 5th root of 16, a squared, b to the 11th times c, times 4, the 5th root of 2, a squared, b to the 5th, c to the 9th. You have 2 minutes. Please begin. All right, how do we go about doing this? Here we go. 5 times 4 is 20, and 2 times 1 is 2, so 20 over 2 is 10. So I know when I combine these, I end up with 10. Now, I'm going to go ahead and let's rewrite these two radicals together. When I multiply 16 times 2 is 32. I have a total of 4 A's, a total of 16 B's, and a total of 10 C's. I just want to make sure this is right. 2 plus 2, 11 plus 5, and 1 plus 9. Okay, here we go. So I'm going to look into column number 5, locate 32. I've done that. Go straight across, and it is 2. So this jumps out as a 2. 10 times 2 is 20. So I know I'm going to have 20 out front. Well, what is the next move after that? Okay, now, how many groups of 5 can I take out of 4? I can't take any groups out. There's not even one full group of 5. So remaining inside, don't forget about the nth root, is 4. How many groups of 5 can I take out of 16? 3 full groups. I can take out 3 full groups, but 3 times 5 is 15. I still have 1 more remaining. How many groups of 5 can I take out of 10? 2 groups. Oh, sorry, this should have been a C. That should have been a C. 2 groups. This is my final answer. Let's look at this last one. 1 times negative 3 is negative 3. I don't think that's going to confuse kids. Here's what I think is going to confuse students. When you don't see an nth root, does anybody remember from the video, what is that number? Oh, great job. It's a hidden 2. So 3 times 12 is 36. I have a total of 14 A's. I have a total of 6 B's. So I'm going to look into column number 2. I locate the 36. And in doing so, I go off to the left to get 6. So let me show you. I go 2 down to 36, and the answer is 6. So 6 times negative 3 is negative 18. How many groups of 2 can you pull out of a 14? 7 equal groups. How many 2's can be pulled out of a 3? Out of a 6. 3. This would be the simplified form of this original expression. Okay, so our second learning task for today will be to revisit how do we take something like this answer and how do we rewrite it in proper form. So it doesn't mean that this is mathematically wrong, but it's not proper. So the first thing we're going to do is we're going to take this nth root and we are going to share it or distribute it to both the numerator and to the denominator. Your final answer cannot have a radical on the bottom. So we need to find a way to rewrite this in a way that when I have the rewritten form and I have this original form and I plug them into the calculator, I get the exact same value. Okay? They're going to be equivalent, but one's going to be in proper form. So I want you to look at whatever this nth root is, and I want you to go to that column. Okay, that's what I'm going to do next. So I'm going to go to column number 4. And now I want you to locate where would we find a 2. So 2 in column 4 would be between 1 and 16, correct? And we're going to grab a calculator next, and we're going to work ourselves down. So locate where is this numerical value, in this case 2, so it's between 1 and 16, and we're going to work ourselves going straight down. And one by one, we're going to divide. What am I going to divide? I'm going to start by dividing this value by 2. If I don't get a whole number answer, I just keep going. So here we go. 16 divided by 2. Oh, I get a whole number. When you achieve a whole number, you take this whole number, that's the key, and we're going to multiply it. We're going to take this and extend both the top and the bottom. We're going to multiply by 8 in this case. And if you're wondering why are we doing that, our whole goal is to rewrite this, keeping this value exactly the same, but ending up with no radical in the denominator. Okay, so here we go. So in the top, I have the 4th root of 8, and on the bottom, I have the 4th root of 16. Why is that a good thing? Okay, well, let's go over here and find, here's the 4, here's 16, go off to the far left-hand side, and it's an answer of 2. So I can rewrite this as the 4th root of 8 over 2. This is the correct answer. A misconception I often see by eager students is, okay, we're supposed to simplify. I'm going to keep going. 8 divided by 2 is 4. These are in different forms, or think of them as not being like terms. I cannot continue. This is it. Now, some students like to rewrite it in this form. They write it as 8 to the 1/4 over 2. These are equivalent. One's in radical form, one's in rational exponent form. They're equivalent. Okay, let's go on to the next one. We're going to go to column 3. So I'm going to rewrite this. I'm going to go to column 3, and I'm going to locate 49. And what I see is in column 3, there's no 49. So then I have to decide what is 49 in between. Okay, 49 is in between 27 and 64. And the past students have said, well, look, how do I know which column to go to? It's the nth root. So we have an nth root of 3. I locate the denominator, 49. It's between 27 and 64. So it's right here. Now I'm going to grab the calculator, and one by one here, I'm going to divide. So I'm going to start with the higher of the numbers as I go down. So 64 divided by, what am I dividing by? 49. So 64 divided by 49. No whole number. I just keep moving down. 125 divided by 49. No whole number. Whoop. Doesn't work. It finally works. As soon as you get that whole number, this is the magical number that we're going to multiply by. So I come back here. I extend the top and the bottom because I have to keep the original value the same. So whatever, as long as we multiply by the top and the bottom, I have the same value. Nothing has changed. And now I have the cube root of 35 on top and the cube root of 343 on the bottom. It's hard to see, I know, if you are not close to the screen. Let me darken this in. And you're like, I don't understand, Miss Bradley. I still have a radical in the bottom. So let's go to the third column. Let's locate 343. I've done that. I'm going to go start off to the far left, and I get an answer of 7. So my final answer is the cube root of 35 over 7. Now, what else would be acceptable? I could write 35 to the 1/3 over 7. This is in rational exponent. This is in radical. Can I have a thumbs up to the side or down based on your understanding right now? Okay, you're trying one right now. If this is your problem, you have 1 minute. Begin. So I'm going to go to the 5th column, and I see 16 is not here. So then I go, well, what's 16 between? It's in between 1 and 32. By the way, I should have taken time to rewrite this first of all. Okay, so 16 is in between 1 and 32. So I'm going to start by taking 32, the larger of the two numbers, and I'm going to divide it by 16. If it's not a whole number, I go on to the next one. Ooh, it is. This is this magical number. So I'm going to take the top and the bottom by 2. Times 2 times 2, I have the 5th root of 6 over the 5th root of 32. Now I come back here. The 5th root of 32 is equivalent to 2. Final answer is 5th root of 6 over 2. Or 6 to the 1/5 over 2. Start with a very simplistic problem. Very simplistic. If I asked you to simplify this, I would want you to understand that when you are multiplying, you have the same base you add. So 10 and negative 2 is 8. 8 and 7 is 15. Simple enough. The bottom 3 and 1 is 4. Great. But now we're not multiplying, we're dividing. What do we do when we divide? We take the top exponent, subtract the bottom. 15 subtract 4 is 11, and this would be my final answer, okay? Wanting you to recognize that. Let's try one more. This time I have x squared times x to the negative 3 times x to the 12 over x to the 11 times x to the 13. All right. What do we do here? Well, 2 and negative 3 is negative 1. Negative 1 and 12 would be 11. 11 and 13 would give you 24. So again, I take the top exponent minus the bottom, and I end up with a negative 13. Now, what's the difference with the top example and the bottom example? In the bottom example, I have a negative exponent, and we have learned that we want to rewrite with no negative exponent. It goes on at the bottom and it's happy. We're going to now apply this to more difficult problems. So what we're going to do next is we're going to look at this particular problem right now. I'm going to zoom in here. Let me zoom in. And you're going to grab your calculator. Please grab your calculator. This is the problem we're going to practice. Okay, so we're going to go through this very slowly and understanding when you need to use parentheses. I'll zoom out here. So the very first part is I need to rewrite this in rational exponent form. That is equivalent to 1 over 7 for this first term. So 1 over 7, I'm multiplying with the same base, so I'm going to add plus 2 over 5, make sure you use in parentheses, plus negative 1 over 10. Now get an answer. What I do not want you to do is I do not want you to take this irrational decimal and then you can simply estimate it. Because if we estimate now and we estimate later, we're not going to have an actual exact answer. So what we're going to do is we're going to turn it back into a fraction. Please hit math on the left-hand side and now press enter twice. And we're going to write this down. This is you showing your work. I'm telling you exactly what to do for your quiz. So the numerator is x raised to the 31 over 70. Now let's take care of the denominator. The denominator, if I rewrite this in rational exponent form, is x raised to the 1/5, okay? So I've simplified the numerator and I've simplified the denominator. What do I do next? When we're dividing, we take the numerator, make sure it's in parentheses, and we subtract the denominator. Can you do this all in your calculator? Yes. This is you showing work. Everything else is on the calculator. I get an answer. It's positive. That's awesome. I turn it back into a fraction, and here's my final answer. X equals 17 over 70. Why don't I have to move this to the bottom? Because it is a positive exponent. Grab your calculator, please. You're going to have a large fractions here, so don't be intimidated by those. This is your last problem for today. Please look right now at number 9 and please complete it using a calculator.